To actually start with the tutorial part of this module, we'll use the Jupyter Notebook. What Jupyter Notebook does is it provides an interface which is okay, let it launch, then I'll show you. Okay, I have to allow root. So yeah, this launches my Jupyter Notebook. So what Jupyter Notebook does is I'll directly jump into the repository. So what Jupyter Notebook does is it gives you access to these notebook format of files in which you can run your code, and you can see your code running as you go along and write the code without interfering with other parts of code that you would be writing. So for example, if I write for example, let's say I write print hello world here and I execute it, then I write print by. As you can see, as I type print hello world and run this portion of code, doesn't get affected. If I just run this, let's first say the output isn't there for this portion, and the output isn't there for this portion either. So if I just run this part of code, the other part doesn't get executed. So yeah, that's what Anaconda does. It lets you separate your code in smaller portions that you can run and actually see the output and debug your code easily. So let's directly jump into the theory of Python. So to understand Python better, let's first understand what's the difference between an interpreted language and compiled language. Most of you already might be knowing it, but let's go over it again. Interpreted and compiled. So what difference do these have? So what happens is for an interpreted language, the interpreter of the language goes line by line, executing the code line by line, and after each line it produces the output, then goes on executing the next line, goes on executing the next line. In compiled code, what happens is an object code is generated first. Means the compilation is done first, then the code is executed at once rather than getting executed line by line. So Python is an interpreted language, so it executes, and in compiled language it compiles and then executes, right? So that's the basic difference between an interpreted and compiled language. It directly gets executed, it gets compiled into an object file, then gets executed. So now let's jump into the discussion of data types in Python. So data types in Python. So the data types, there can be various data types and object types in Python, but the basic ones that we'll be discussing are integers, floats, dictionary, then lists, as known as C or C++ as arrays, then tuples, and of course strings. So these are the different data types that we'll be discussing. The very first one is integer. So how does Python interpret an integer? So it's as simple as it's in C or C++. You just write the integer and Python interprets it as integer. How do you know it's an integer? You use the type keyword or type function, put down the value, and it says it's integer type. So how is assignment of an integer or any other variable for that matter is done in Python? So the C format of assigning a variable is something like this: int a is equal to 25. So it would know the language would know, the compiler would know that it's an integer. In Python, you don't actually have to specify the type of data. You can just directly write a is equal to 25, and you don't need this semicolon. You can use the semicolon, but it's not required because Python differentiates different block or different lines of code on the basis of indentation. What indentation is that this number of spaces or the tabs that you actually put down. So for example, if I have to declare that for I in range, and don't worry about the code, I'm just showing you how the code is put in Python in different blocks. For I in code, for I in range 100, print I. This in C you would something like this: I is equal to 0, I is less than 100, I plus plus. So this defined the block. Right now this space is actually defining the block. It's telling the Python interpreter that this block is different from this block. So this is external block, this is internal block. So for nested for loop will be for j in range 100, print I into j. So this block is different, this block is different, and this block is different, and all these are nested in one inside the another. So that's how Python knows that knows how one block is different from another block. So yeah, you don't, getting back to the assignment, you don't have to explicitly specify. Python will automatically know that it's an integer based on the type of value you pass to it. So if I do type A, it says integer. So to execute each block of code, just press shift and enter at once. It will execute that portion of code. So if I go and say type A and change the value to 5.4, it will start saying that it's a float, because the interpreter is knowing based on the data that I passed that it's a float and not an integer anymore. Then let's get into list and how they're different from arrays in C or C++. So in C and C++, arrays basically were collection of similar type of data put together, right? So arrays were a similar kind of data that were put together. But here in C, let's do this. But here in Python, lists, what lists are, they are collection of data. They're just collection of data. Their data types don't actually matter. So these are collection of data. Their data types can be different, and different kind of data can be grouped together and be called as lists. So for example, x is equal to 1, 2.5 and apple is a valid list in Python. So if I execute this portion executes well enough. And now if I try to get to know the type of x, it says it's list, right? So list in Python work in this way, that we can put different kind of data in one group and they would be called as list. So other similar type of data, similar data type related to list is known as tuple. So what tuple basically is, it's also a collection of data, but it differs from list in that way that it's immutable and lists are mutable. So for example, let's say tuple 1, 2.5 and apple, it executes, and now if I type get to know the type, it says it's tuple. So to know the difference, let's try and reassign the value. For example, let's say I want to reassign I made a mistake and put down 2.5 mistakenly. So the values in lists and tuples start from 0, similar to C. Means the indexing of any list or any tuple starts from 0 as well, as it was doing in C. So if I say x0 means 0th index of x, it returns 1, and then if I say 2, it returns apple. So if I want to modify the value at index 1 in list x, I'll say x of 1 is equal to, for example, let's say 1.25. It executes successfully, and now when I check what x is, it says 1.25 as the reassignment and apple. So now let's go ahead and try to do the same with the tuple. So tuple 1 is saying 2.5 right now. Let's try to change it to 1.25. We'll get an error because tuple object do not support item assignment. What does this mean? This means that tuples are immutable and the values that we first assign in tuple cannot be changed after they are assigned. So to get a better understanding of this, let's do this. Let's say id of x is this. Now, what is x as of now? X is this right now, and id of x is this. Cool. So now if I say let's modify x and make it okay, let's make x2 ball now, right? So now x is 1, 1.25 and ball. Now let's again go ahead and check the id for x is the same id. Id basically is the address or memory address of the particular variable that is stored. So it says that its value is changed but the location is still the same. Now let's go ahead and try to do the same with a tuple. So tuple tup is this. As we saw that tuples are immutable, they cannot be reassigned, but there can be a fairly simple solution that let's say we just go and we just change the values in a tuple and reassign it with this, the new values. Yeah, this executes. Let's check. Let's say our initial tuple was this and the id for that tuple was this when initially we assigned these values to the tuple. Now when the tuple is changed to this, and now when we try to get the id as visible, the id is different, 312 and it says 632, means the address of tuple changed as we change the values of tuple or made a reassignment to the whole tuple. So what it actually indicates is that the original tuple was stored in memory somewhere here and the variable name tup was pointing here. Now what happened, when we changed the values, a new tuple got created somewhere else in the memory and the name tup started pointing to that tuple rather than this tuple getting modified as the list got. So yeah, that's how tuples and lists are different from each other. One is mutable, another isn't. So let's jump into something called as dictionary, right? So what do you understand by a dictionary? It's a collection of keys or it's a collection of some word. For example, let's say take an example of English to Hindi dictionary. What happens is if I go and search for the word apple, so I know that apple exists in the dictionary, and then when I search for the word apple, it tells me what apple actually means. So so dictionaries in Python work the similar way. The word apple there is actually what we call in Python the key of that particular dictionary, or one of the various keys. Apple, ball, cat, all these are keys of that dictionary, and the Hindi version or what the Hindi translation of it is known as the value. So for example, apple is the key and the meaning of apple, let's say safe, or let's say fruit as of now. So this particular thing is the value and this particular thing is the key of the dictionary. So how do you define a dictionary? So the syntax for a dictionary is as simple as this. So let's say apple is a fruit. Let's say ball is a toy, cat as an animal. So what does this dictionary actually make sense to you? As you can see, we are trying to assign the types of these objects. Apple is a fruit, ball is a toy, cat is an animal. So let's go ahead and name this dictionary as types, right? So this dictionary is named as types. So when we go ahead and do types dot values, it shows you all the values that are stored. and if I go ahead and do types.keys, it shows you all the keys. So if I try to ask the type dictionary what is the meaning of apple, it will say, okay, execute it first. Sorry, types apple. It says that the meaning of apple in the dictionary types is fruit. If I go and say that no, apple is an vegetable. So now if I go and ask what apple is, it says vegetable. So what it basically does is it stores keys, and it stores the value for that key, and whenever we query for the key, it tells you what the key translates to, or what the meaning of that key in the dictionary is. So that's how dictionaries work. And string, like in C or C++, what happens is in C or C++, string is collection, no, not collection, it's an array of characters, right? And in C++, let's say string is a class as well, right? So in Python it's just an data type, right? So in Python it can either be just a one-lettered character, or it can be multiple lettered string, doesn't matter. And to put character or string, you can use either single quotes or double quotes. So I can put an entire string in a double quote or single quote, or I can do it in double quotes as well, right? So it won't make any difference. So I can say string like this, I can say just a character like this. If I go ahead and do type of x, it will say string. If I go ahead and do type of string, it will still say string. So the good thing about Python and string is it comes with additional functions and methods. So you can directly use capitalize, case fold, center, and all these functions is lower, is upper, all these checks as well, without putting much effort into all these things, basic things. Other than that, how to print in Python, you just say print and put whatever you want to print in comma separated values. So print apple 1 and 1.25. It prints apple 1 and 1.25. If I want to end this with a new line every time I print, I'll just say end is equal to new line, and it will print everything in new line, which basically is missing from here. And if I want to print different statements, I don't have to repeatedly tell Python that print one. So what it will do, it will directly print in new line. I don't have to explicitly tell go ahead and print this the next value or the next print statement, execute the next print statement in new line. So right, to get input in in Python, what you actually have to do is directly write the input, and it will ask for you for the input. For example, I can say A, and it will take input A. So what happens is you can input any kind of data or any data type with this function. What you have to do is you have to typecast that into whichever data type you want. So typecasting in Python is fairly simple. So if I say I want to convert this string 1 into an integer, I do int. If I say I want to convert this into float, I do this. If I say let's say I want to convert this tuple into a list, I can do this, and it will convert this into a list. So it's fairly simple in Python. So whenever I get an input, I just say convert it into an integer, and when I say 1.2, it says it's invalid because it's typecasted an integer and 1.2 is not an integer. So it makes the check for you. If I say 1, it takes the input 1. If I say anything that is not integer, it will say it's a different data type, and I can't actually take that as input for this particular statement. Going forward now, and this covers all the basic theory of Python programming. So that would be fairly simple for you to understand. And if you still don't get anything, there are resources in the repository. I'll encourage you to go to the repository and check these resources, these books. These will help you to get a better understanding of it.